Arc sine of 15 pi 11ths. Arc sine of 15 pi 11ths. Okay, so these are inverse functions of each other. Would you agree? Arc sine of sine. So when you compose two inverse functions back to back, they typically just undo each other, right? You start with something, you move two steps to the left, then two steps to the right. You're back where you started. So the answer could be 15 pi 11ths, right? It could be. But is it? No, no, it's not. It can be 15 pi 11ths because it's not in the PVR of arc sine. On the unit circle, the PVR of arc sine, remember, is quadrant 1 and quadrant 4, which means it's from negative pi halves to positive pi halves. So remember how we do this. Freeberg did it yesterday. We got to figure out where 15 pi 11ths lives. And where does 15 pi 11ths live? Quadrant 3. Remember how we decided that earlier in the year? We said that pi was 11 pi 11ths. Half of 11 is 5.5 pi 11ths. So now we have our quarter cycle counting interval. What's 11 plus 5.5? 16.5 pi 11. So now I know where 15 lives. 15 lives somewhere over here in quadrant 3. Remember doing this? Man, I'm having bad deja vu from earlier in the semester. Oh, yeah. So what do I know about the sine of this angle? Is it positive or negative? It's negative. What's the other quadrant where sine is negative? Quadrant 4. Is that the one in the PVR? It is. So I don't go all the way around to get there. Rather, I go straight to it. I go straight to it like this. I just need to figure out the what angle? What's it called? I need to figure out the reference angle. And so we got 11 here and 15 here. How far is it from one to the next? 4 pi 11. So, okay, so now I got to rotate clockwise 4 pi 11ths, which means my answer is going to be what? Excellent. We don't even have to have 15 pi 11ths on the unit circle. We just have to know how to do what we just did right here. And we know how to do that. We've already done this in class. We've tested over this, right?
So on the quiz tomorrow, how many questions like this?
You'll have one for sine for sure. You'll have one for cosine for sure. Yeah, I'll probably give you about 5 questions on the quiz. Yeah, 5 questions on the quiz. So let's pick up with example 9. I think that's where we are. Example 9 is where it gets interesting. It's where we start doing what we just did for sine, but we're doing it for cosine. So remember yesterday we learned about arc cosine. Arc cosine has a PVR that is the arc cosun on the horizon, right? It's from 0 to pi, 0 to pi. You'll never get a negative angle, but if you got a positive ratio, it's a positive acute angle. That's going to be true for all of them. Every single trig function, if you start with a positive ratio, you're going to get a positive acute angle. The question is, what happens if you get a negative ratio? For arc sine, it's a negative acute angle, but for arc cosine, it's a positive obtuse angle in quadrant 2. Okay, so we do the same thing here with cosine. If we start with a ratio and we take the arc cosine of cosine, it's going to just be the ratio. It's going to be what you started with so long as it's a legal ratio. As long as it's between -1 and 1, it's going to undo itself. The trick, though, is when you start with an angle, like we just saw in the warm-up. If you start with an angle and you're taking the arc cosine of the cosine of that angle, it may not be x, okay? It will be x only if it lives in the PVR. If that angle you start with lives in the PVR, you're in luck. Those are the boring ones, right? I tend not to like those because they're too boring. But if it's not in the PVR, you do exactly what we just did for arc sine. You just do it for arc cosine. Okay, you look to see where the angle x lives. You find the reference angle. You see if it's positive or negative there, and we got an announcement.
Good morning, unicorns. Folks, as you know, we have English 2 USC testing going on this morning in the 100 and 800 hallways. So that part of the building is not accessible to anybody else who's not testing this morning. Teachers, if you are not testing and you have students in a regular classroom this morning,
that's us.
During class time, please keep all students in class. Students, please do not request to go anywhere for these morning classes. We'll allow movement in the afternoon, but this morning, because testing is going on, teachers, again, please keep all students in class. Please do not release them for class for any reason unless they are called to the office. Again, because of testing, we want to keep the hallways clear so that we can focus on the testing area. Again, that's for the morning. So students, you're going to remain in class. If you need to use the restroom, you have to do that during passing periods. The bells are off this this morning so we don't disrupt our testers. Again, non-testers, teachers, please keep those students in class, every class period until we're finished with testing. We will come on later in the day when testing is finished, and we will turn the bells back on in the afternoon. Students, if you're testing, good luck. Mark all the right answers, and take your time. Thank you.
You know who else needs good luck besides testers? People with full bladders. Whoa! Good luck. Good luck. We're about as far away from the testing hallway as we could be, but I understand. They don't want people roaming the halls. Y'all aren't the ones that roam the halls. Y'all go do your thing upstairs and you come right back. But there are people, believe it or not, I've heard of such a thing, where they leave the room and they wander around the hallway. They're not as excited or intent on getting back to the classroom as soon as possible. So I understand. A few bad apples ruin it for everybody. But we'll treat it kind of like we would in a lockdown situation. If you need to pee, I'll use my trash can over there. We'll put it in the corner. I've got some sleeping bags for fun night. I can hang those from the ceiling tiles and make kind of like a privacy curtain. And we can do it that way because they're testing on the opposite side of the building. Inverse cosine of 3 pi fourths. I get it, though. I get it. It's the few bad apple kind of thing. Um, is this just going to be 3 pi fourths? Yes, because where does 3 pi fourths live? In the PVR in quadrant 2. So it's just going to be 3 pi fourths. Yeah, there you go. That's good. All right. Letter B. Arc cosine of 7 pi 6. Is it just 7 pi 6? No, because where does 7 pi 6 live? Quadrant 3. Now, here's how we do it. This is a unit circle angle, so we can actually work it out from the inside out, but we don't even need to. We know the reference angle is going to be the same. In quadrant 3, is cosine positive or negative? It's negative in quadrant 3. What other quadrant is cosine negative in? No. Quadrant 2. Is quadrant 2 in the PVR? Yeah, so I need the angle in quadrant 2 that has the same reference angle, which is pi 6. What's the pi 6 angle in quadrant 2? 5 pi 6. There you go. That's how you do it. It's fun easy, right? Just like holding your bladder. No. Negative 5 pi 6 would be coterminal with 7 pi 6. That's negative 5 pi 6. Remember, for arc cosine, you're never going to have a negative angle, ever. Ever going to have a negative angle. Now, if this were arc sine or sine of 7 pi 6, we would have to do negative pi 6 because we'd have to be in quadrant 4. But that's why for cosine, it's the arc cosine on the horizon. You can even draw like little, you could do this, watch, the arc cosine on the horizon. You could shade it yellow, and then you can make like little yellow lines. When you were little, there was a lot of ways to make sun rays. You can make them squiggly like this, or you can make them straight. And then there was the option of like alternating, remember? Long, short, long, short. Remember doing that? All kinds of different ways to make sun rays. It's just whatever fancies your fancy. Whatever floats your boat. All right, let's move on to this one. Inverse cosine or cosine of the square root of 2 over 2. This one's a little different now because we're starting with a ratio. Or is that an angle? Ah! I tried to trick you, but I can't trick y'all because y'all do y'all's homework. It looks like the ratio square root of 2 over 2, doesn't it? But how do I know it's an angle? It follows a cosine, not an inverse cosine. It follows a cosine, not an inverse cosine. So this is just some radiant measure of an angle. Does anyone know what the square root of 2 over 2 is approximately? It's got to be less than 1, doesn't it? It's less than 1. So which quadrant would it live in if it's less than 1? It would live in quadrant 1, right? That's because square root of 2 is 1 point something. 1 point something divided by 2 is going to be less than 1. Is quadrant 1 in the PVR of arc cosine? It is. So guess what the answer is going to be? The angle square root of 2 over 2. Yes, yes. Okay. Context clues. You can't just look at numbers. You got to look at the context of the number. Cancel. All right. Letter D. Cosine of arc cosine of negative 0.5. Is negative 0.5 an angle or a ratio? It is a ratio now because it follows arc cosine. Are ratios always good? Can we just undo it if it's cosine of arc cosine? Will they always undo each other? Yes, as long as it is a legal ratio. Is it a legal ratio? Is it between -1 and 1? It is. Right? It's between -1 and 1. So it works. It's just negative -0.5.
What happens if it's not in between -1
You put D and E.
and 2? Okay.
Yeah. All right. This is like one you'll have on the quiz tomorrow. Inverse cosine of 23 pi sevenths. Why don't you take a minute to do that one on your own? And I'll do it quietly up here and we'll compare answers. Sound good? It might be 23 pi sevenths. I don't know. I doubt it. Man, I got a lot of numbers written up there. Does anyone know what the answer is? 5 pi sevenths? Anyone else think it's 5 pi sevenths? You think it's 2 pi sevenths? What's 2 pi sevenths in this problem? The reference angle. Yeah, so very good. If you can find 2 pi sevenths as the reference angle, that's this blue size right here. What is the value of cosine in that quadrant? Positive or negative? It's negative. What's the other quadrant where cosine is negative? Quadrant 2. So we need to get to the angle in quadrant 2 that has the same reference angle. So this right here is going to be 2 pi sevenths. But what is the angle that we need to rotate from 0 to get over to that terminal ray? We got to stop 2 pi sevenths short of the x-axis, which is 7 pi sevenths. So what's 7 minus 2? 5 pi sevenths. 2 pi sevenths is the reference angle. You can do it one of two ways. You're counting by 3.5 pi sevenths, so you can just keep going. It's more than one rotation, right? So if you go around one time, you get 14 pi sevenths. You can keep going. 17.5 pi sevenths, 21 pi sevenths, 24.5 pi sevenths, and that tells you that it lives 23 pi sevenths lives in quadrant 3. How far is it from 21 pi sevenths to 23 pi sevenths? 2 pi sevenths. Or you could do what I did on the right-hand side of the column. You just know it's more than one rotation. So 23 minus 14, you get 9 pi sevenths. So 23 pi sevenths is coterminal at 9 pi sevenths. Where does 9 pi sevenths live? It lives between 7 and 10.5. How far is it from 7 to 9? 2 pi sevenths. And then once you have the reference angle for cosine, you got to get into quadrant 3 typically. And so it's going to be 1 or pi minus that answer. If it were arc sine, it would be easy, right? Arc sine, the answer would just be negative 2 pi sevenths. We would just rotate straight down into quadrant 4. These are fun, aren't they? Capital fun with a capital F. Fun, yeah. Fun. You can't spell fun without foo. Nope. You just have right. Okay. Are y'all okay with arc sine and arc cosine now? You know the principal value range of each of those. Okay. It's time to meet the third and final one. We're not going to look at secant, cosecant, and cotangent. The last one for which you are responsible is tangent. Okay, so we're going to do the same thing we did with the others. We're going to draw a couple of cycles of tangent. Tangent, we'll go pi halves here, and we'll go pi right there. I think that's enough. Negative pi halves and negative pi. I think that's good. What does tangent have at the origin? Is it an inflection value or is it a vertical asymptote? An inflection value, good. So there's an inflection value at 0. There's a vertical asymptote at pi halves, an inflection value at pi, vertical asymptote at negative pi halves, inflection value at negative pi, and it's a monotonic increasing function. So it looks like this. All right, so I have two cycles of tangent drawn. The first, the half in the front, the half in the back make one. All right, so is this a one-to-one function? If you want to continue it on like this without labeling it, you can. Is this a one-to-one function? It is? Well, let's review. To be a function, it has to pass the vertical line test. Does this graph pass the vertical line test? Yes, so it's a function. To be a one-to-one function, it has to also pass the what? The horizontal line test. Does this pass the horizontal line test?
When a graph like this repeats itself over its domain, it doesn't like.
It won't pass the horizontal line test because notice it fails it miserably. To pass the horizontal line test, just to review what the test is, you draw a horizontal line, it cannot touch the graph more than once. Because if it touches the graph more than once, that means you got multiple values of x that just the exact same y value. And now you got that single y value that's not just two timing, it's three timing, it's four timing. That y value is seeing multiple partners. That is not a faithfully monogamous relationship. Now each of the x's are only seeing y. They each think that y is their one true love. But unbeknownst to them, y is seeing other partners behind their back. Not Minnie and Mickey Mouse material, right? Not faithfully monogamous. So it fails the horizontal line test. So we got to do the same thing we did with arc sine and arc cosine. We have to restrict the domain to the three criteria, remember, where it has to be convenient, which is near 0, it has to be a one-to-one interval, and it has to include all of the tangent values from negative infinity to infinity. Negative pi halves to pi halves. I like that. Now, we have to use parentheses around negative pi halves and pi halves, don't we? Because they are not part of the domain. So, yeah, you're right. If you just look at this principal branch, remember back in the day, we called this the principal branch? It's the main branch. You could use that main branch and the main branch only. And if you reflect that graph across the line y equals x, let's go ahead and label this one as f of x equals tangent of x. If you reflect that across the line y equals x, you get the new function f of x equals either inverse tangent of x, or we use the same notation arctangent of x. Here's what the graph is going to look like. This one is really the most important of the three. In fact, I'm not going to require you to memorize the graph of arc sine and arc cosine, but I do want you to memorize the graph of arctangent. Okay? Memorize. Now, let's think about the vertical asymptotes. What happens to a vertical line when you reflect it across the line y equals x? It becomes a what type of line? No, not diagonal. If you reflect it across the diagonal line. Well, what happens to the x and y axis? Don't they switch? The x and y axis interchange. So a vertical line becomes a horizontal line, and a horizontal line becomes a vertical line when you reflect it across the line y equals x. So your vertical asymptotes at negative pi halves and pi halves turn into what? Horizontal asymptotes at positive pi halves and negative pi halves. So we'll draw those first. Those are guidelines. It's going to remain an increasing function. It's going to look like this. It's going to do that. There's the graph of inverse tangent. This one is important to memorize, especially if you go on to take calculus, because this one shows up quite a bit. All right, what is the domain of this function? It's the range of tangent, which was all real numbers. Yeah. So this one has an unrestricted domain, which means what ratios are allowed? All ratios, or any ratio. Yeah. All ratios are allowed. What's the range? What angles do we get out here? We only get out the angles between negative pi halves and pi halves, non-inclusive. See that? Non-inclusive. Non-inclusive. That's very similar to the PVR. You can put PV in front if you want. PVR. That was very similar to the PVR of which other inverse trig function we've talked about? If no, let's look on the unit circle. Yeah, it has to be arc sine then, doesn't it? It's going to be positive in quadrant 1. Tangent's positive in quadrant 1. It's negative in quadrant 4. It goes up, but we have an open circle there, and it goes down, and we have an open circle there. So this is also the half moon, isn't it? Which, for the most part, is the same as arc sine, minus the endpoints, right? Minus the endpoints. So that's kind of cool. You don't have to memorize a whole nother PVR. You just like, okay, arc cosine on the horizon is the odd man out, isn't he? Arc sine and arc tangent now have the same PVR for the most part. And arc cosine on the horizon. We don't say sun on the horizon because that makes it sound like sine. It's cosine. Cosine on the horizon is the oddball out. The others are the half moon. Okay, now this one also has a couple of other features. Does this one have any symmetry? Arc cosine didn't have any symmetry. It does. What type? Y-axis symmetry. Origin. This is origin symmetric, which means it's an odd function. Now, this one also has n behaviors. Watch this. What would be the limit as n goes to infinity of arctangent of x? Pi halves. It has horizontal asymptotes, so it has n behavior. The others don't have n behaviors. All right, and over here, what would be the limit as n goes to negative infinity of inverse tangent of x? Negative pi halves. Those are the two important results of arctangent when we're applying it to higher order math in calculus. Those limits of arctangent show up quite a bit when we are evaluating what's called an improper integral. Okay, when we know that the n behavior converges to pi halves, we know an improper integral converges as well. Pretty cool. Okay, so this one has n behavior, the others do not. Arc cosine is the only one without any symmetry. Arc sine was also an odd function. Yeah, there you go. There's arctangent. All right, so guess what? We do the exact same thing now. What's inverse tangent of 1? We're talking about the function now. Well, think about the PVR. I'm putting open circles there now. It's a positive ratio, so it has to be in quadrant 1, right? Remember, all three of them, arc sine, arc cosine, and arctangent, have PVRs that include quadrant 1. So if you're taking the arc sine, arc cosine, or arctangent of a positive ratio, unless it's a quadrantal angle, it's going to be in quadrant 1. So the other way to read this, instead of just inverse tangent of 1, is to ask yourself, what angle in quadrant 1 has a tangent value of 1? Ah, there you go. You were thinking through it. We want the angle. It's pi fourths. Because what's tangent of pi fourths? 1, right? Because they're both square root of 2 halves there. Now, follow-up question. What's tangent of 5 pi fourths?
Negative 5/4? Negative 1.
No, I'm looking for the ratio. Tangent of the angle 5 pi fourths.
This would be negative 4. Or no, positive.
It's positive 1 because it's in quadrant 3 where x and y are both negative, right? And the negatives divide out. So tangent of 5 pi fourths in quadrant 3 is also 1. So now the follow-up question of that, why then is the inverse tangent of 1 not also 5 pi fourths? Not in the PVR. We restrict it to one answer and one answer only, and we agree upon where that answer is going to live, between negative pi halves and pi halves. Good. Questions on A? Letter B, letter B, letter B, oh, letter B. There is an arctangent, let it be. Very good. We know it's going to be in quadrant 4 because it's a negative ratio. So I know it's going to be a negative acute angle. I'll get the negative out of the way. It's going to be a negative acute angle. Now, you got to remember which angle. It's got to be the pi 6 or the pi thirds, right? Because pi fourths always gives you tangent and cotangent of 1. So which one gives you this one? Was it the pi third or the pi 6?
It'd be the I.
Are you sure?
Yeah.
Yeah, what would be the ordered pair down there at negative pi thirds? It would be positive 1/2, negative square root of 3 halves. Correct? Is that the ordered pair at negative pi thirds? And tangent is y over x. So that would be the negative square root of 3 over 1, which is negative square root of 3. Is that what we have? Pooper scooper. Good thing we can check our work, right? Good thing we know how to check our work. Maybe it's this one, which is positive square root of 3 over 2, negative 1/2. That would be negative pi 6. What is the tangent of negative pi 6? Well, now it's 1 over the square root of 3, negative, which when we rationalize it gives us negative square root of 3 over 3. I don't expect you to flat out memorize that it's a pi 6 angle. If you want to, you can, but you should be able to deconstruct it. You should be able to say, if it is pi thirds, let me check it going forward. It didn't work. Therefore, it must be the pi 6, and let me check it. It does work. Got it? You don't have to be lightning fast when we're going backwards. I expect you to be somewhat proficient going forwards. Like if I ask you for tangent of pi 6, you should say eventually, within the first hour, square root of 3 over 3. Somewhat proficient within an hour or so. Less than or equal to an hour. Inverse tangent of 0. Look, look. First of all, it can't be D and E because this is a ratio. And what are the allowable ratios for arctangent? All ratios are allowed. So it's a legal ratio. But we're looking for the angle. We're looking for the angle where the tangent is 0. It's 0. No, it's 0. Think about the graph of arctangent. Doesn't the graph of arctangent pass through the ordered pair 0, 0? Just like the graph of tangent does? So tangent of 0 is 0, and inverse tangent of 0 is also what? 0. They both pass through the origin. Yeah, okay. Arctangent of 30. Is 30 an angle or a ratio? It is a ratio. It is a ratio. Is it a legal ratio? That seems awfully big.
No, all real numbers.
Yeah, all ratios are allowed. This one is all accepting. Now, is 30 a unit circle ratio? No. What quadrant will it live in? Do we at least know the angle quadrant? It's quadrant 1. Okay, so it's going to be somewhere way up here. Now, to find that, we would have to go to the calculator. And if we do it in radians, arctangent of 30, let's see if I can pull it up here. Come on, Minnesota. Minnesota. The state bird is the mosquito. You want it in degrees or radians? Let's do it in radians. How do we type in arctangent? Ooh, 1 over tangent would be cotangent. We hit second tangent of 30, and we get 1.537. 1.537.
You ever have Minnesota calculator?
I'm hoarding them. I don't want them to take them away from me. More is better. More browsers. More browsers. Minnesota, 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 Minnesota. Too bad it's not like Spotify where they get like 0.003 cents for every time we use it, right? We can add to the Minnesota coffers. Yeah. Okay, cool. Now, the fun part. When we start doing tangent of arctangent or arctangent of tangent. Okay? Let's do it. If we start with x behind an arctangent, that represents a ratio. If we then take the tangent of that, will it always be x?
Yeah.
If you start with a ratio, it's always going to undo itself so long as it's a legal ratio, correct?
No ratio.
And what are the legal ratios for arctangent? All real numbers. So this is the only thing that's a sure bet in life when we're talking about these trig of inverse trig. If it's tangent of arctangent of something, it's always going to be that something all the time. As long as it's a real number. You can't say like 11 or something like that.
So no matter what, if the inverse of something is inside of the parentheses, that ratio
As long as it's a legal ratio, that will be your answer. It's when you start with an angle that you have to be cuidado. Yeah. Speaking of cuidado, if we start with an angle and we take the arctangent of the tangent of that angle, it may or may not be x. It depends on where that angle that we start with lives. If it lives in the PVR, we're good. What's the PVR of arctangent? Negative pi halves to pi halves, non-inclusive. If it is an angle that is not in the PVR, the answer is not DNE. The answer is we got to figure out where that angle lives, what the sign of the tangent value is in that quadrant, find the reference angle, and then get into the right quadrant where tangent has the same sign, like we did in the warm-up, like we did for the arc cosine. Those are the fun ones. These are the fun ones. Remember, you can't spell fun without un. All right, example 12. Evaluate the following compositions without a calculator. Oh no, without a calculator, what am I going to do without Minnesota by my side? Pray. Inverse tangent of 7 pi fourths. Why is this capitalized?
because
No, it's just another way to impress upon you that we're talking about inverse tangent, the function with one output in the PVR and not the operation where you can have multiple. All right, so it's inverse tangent of tangent. I do know that they could undo each other potentially. They could potentially undo each other, and the answer could be 7 pi fourths. If this were a multiple choice question, guess what one of the answer choices would be? 7 pi fourths. And it might be answer choice A, maybe. So if you have a low emotional quotient, you're like, ooh, there it is. But is 7 pi fourths in the PVR? The PVR is negative pi halves to pi halves. And where does 7 pi fourths live? No, it actually does live in quadrant 4. But to get there, we don't go straight down to it. We go what? We go all the way around. So this is good. We're in the right quadrant. We don't need to find the reference angle and get into the right quadrant. We're in the right quadrant. We just need to get there by going directly to it clockwise. So what's the answer? Negative pi fourths. Yeah. Those are coterminal with each other. The angle that we started with was coterminal with the correct answer. Questions on A? Letter B, letter B, letter B, oh, letter B. The answer is negative 1,000.22. Why, Ryan? You're right.
because it's a real number and it's an inverse of ratio.
It's a ratio. There, that's what I was looking for. And it's a number. And of course, because it's a real number, it's a legal ratio. Yeah. And so the tangent of the arctangent will just undo each other. And because they're inverses, you got to be careful. We're going to be looking at compositions of mixed functions like sine of arctangent and cosine of arcsine. Okay. But if it's the same function's inverse, tangent of arctangent, it'll undo itself. Okay. How about this one? Arctangent of tangent of negative 4 pi thirds. We're starting with an angle, aren't we? We have inverses, which is good. We have inverses, but where does negative 4 pi thirds live? Ugh. Quadrant 2. It lives over here. It's negative 4 pi thirds. Yeah, it's going clockwise. Now, is quadrant 2 in the PVR? No, the PVR is this right here. So we do the same thing we did for arc sine and arc cosine. In quadrant 2, is tangent positive or negative? It's negative. What is the other quadrant in the PVR where tangent is negative? 1 or 4? 4. So we need to get into quadrant 4. We need to get over here into quadrant 4. And to get there, we need to go straight down to it like that. So it has to be a negative angle. Yes, yes? And what's the reference angle for 4 pi thirds? Just pi thirds. Yeah. Because this is negative 3 pi thirds, remember. So the reference angle is pi thirds, so we just go down negative pi thirds, and we're there. See? It's fun easy. It makes you think a little bit, which is the whole purpose of this class. Comments or questions on that one?
How come we do the opposite instead of the flip?
Wait, what do you mean the opposite instead of the flip? Can you be?
Like going diagonally instead of flipping it to the positive side?
Oh, let's talk about that. It's because you have sine, which is y over r. You have cosine, which is x over r, and then you have tangent, which is y over x. So, if you're talking about sine, sine is positive. Sine is positive in vertical adjacent quadrants, and it's negative in vertical adjacent quadrants. For cosine, because it's x over r, cosine is positive in quadrants 1 and 4 and negative in quadrants 2 and 3 because it's x, right? The sign depends on the x. And then tangent is y over x. So tangent's positive in opposite quadrants where they're both positive and both negative, and negative when they're opposite signs. Positive, negative, negative, positive. Okay? I've never written this out before because the way I wanted you to understand it was just realizing that r is always positive and x and y can be negative. So if you want to know where sine is positive, sine y, you know where y is positive. Cosine is negative when x is negative, which is to the left of the y-axis, and then tangent is opposite. So that's right. That was a good question. Probably overdue for writing that out. But I don't want you to memorize that. I want you to understand why that is, and then you don't have to memorize it. All right. Any other comments or questions? All right. We could probably accentuate this by doing this. Positive, positive, and then positive like that. So you get the idea easily that it's vertical adjacent, horizontal adjacent, and then opposite quadrants. All right. Guess what? We're at the fun one. This is the one that might be on the quiz. Take a minute to do it by yourself. I'll take a minute to do it by myself, and we'll compare answers, okay? On your mark and set, go. Bless you. Bless you. They're getting 4 pi 15ths? Excellent. 19 pi 15ths, if you split up your quadrantal angles in terms of 15ths, it lives between 15 and 22.5, so it's in quadrant 3. In quadrant 3, the tangent is positive now because they're both negative. What's the other quadrant where tangent's positive? It's the opposite quadrant, quadrant 1. So I know my answer is a positive acute angle, and it's going to be the reference angle. So how far is it from 15 to 19? 4 pi 15ths, and that's your answer. Not negative 4 pi 15ths, positive 4 pi 15ths. Yay! Those are fun. You can't spell fun without fun. You can try it, all right? Un. I'm having lots of un. Someone might know what you're talking about. I'm having so much un. You mean fun? Yeah, I tried to spell it without an F. Didn't work. All right, so far so good?
So on our quiz tomorrow, it's going to be over sine, cosine, tan.
Right.
Okay. Is this going to be on it?
Oh, yeah. But we'll stop right here. Because on example 13, notice we're starting to mix it up. Sine of arc cosine of sine, cotangent of arc sine. Yeah. Start. No, we'll quiz through example 12. Okay. All right. Any other comments or questions? Any good jokes? My suspicions were true. Someone has been adding dirt to my garden without me knowing it. The plot thickens. That is a bad joke.
Do you still have your dad joke book?
I don't know where it's at.